Okay, now here we are. We are now going to continue our discussion on distance formula. Up till now, we have discussed how to find out the distance between 2 points in which either x or y component is same. If I give you 2.5 comma 2 and 5 comma 9, and I ask you to find the distance between these 2 points, you do not need the formula. You can just simply find out the difference between the components which is changing. X component you can see is fixed, but the y component has changed. This is 5 comma 9, this is 5 comma 2. To find out the distance between them, I'll just take out the difference between y components. That will be 9 minus 2, which is 7 units. We have also discussed how to find out the distance between the points in which x component is changing. Let's say 3 comma 0 and 7 comma 0. In these set of points, you can see the x component is changing, but the y component is fixed. So I'll take out the difference between the varying component. 7 minus 3 is going to be 4 units. Now we need to identify how to find out the distance between a set of points in which both the components are changing. For instance, 1 comma 2 and 3 comma 4. This is what we are going to discuss today. How to find out distance between such points in which both the components are changing, and that is where the distance formula comes into use. You cannot just simply subtract the components like the previous cases. Okay, I'm here on the graph paper on the grid. Where is this 1 comma 2? This 1 comma 2 is going to be here. This is 1 comma 2. And where is that 3 comma 4 going to be? This 3 comma 4 is going to be somewhere over here. So these are the 2 points between which I have to find out the distance, and the distance between them is going to be okay. So now this has to be a straight line. Use a scale. So this is the distance that I have to find out. Now I cannot just simply measure this distance just like that. So what I am going to do, I am going to drop a perpendicular from this point on the x-axis. Is that okay? And I am going to drop a perpendicular from this point to this point, or maybe you can continue dropping it to the y-axis, whatever. Okay, so now if you look at this and then this and then this part, what do you see? You see a right angle triangle, definitely. So this is a right angle triangle. I cannot just find out the diagonal distance directly. I cannot find out the distance between these 2 points directly. So what I am going to do, I have formed a right triangle. Read out the coordinates of these points. What could possibly be the coordinates of this point? How far apart is this point along x? This is 3. And what is the height of this point? This is 1. So the coordinates are 3 comma 1. So I have 3 points here, 1, 2 and 3. Can we find out the distance between these 2 points? This is 1 comma 2. There is definitely something wrong. This is not 1 comma 2. This is 2 comma 1. I am not going to change the whole thing. I am just changing the question a little. I am sorry if there is confusion to anyone, but I hope you people can understand it. Anyways, so this is 2 comma 1, this is 3 comma 1. Can you find out this distance between these 2 points? I have taught you how to find out the distance between 2 points in which one component is fixed. So in these 2 components, y component is fixed and the changing component is x component. This distance is 3, this distance is 2. So how much is this distance? This distance is going to be 1 unit only. So this distance is 1 unit. And in the similar way, how much is this vertical distance? Look at this. What is this distance? 1, 2, 3, 4. And what is this distance? 1 only. X component is 3 in both the points. So this height is 4 from the x-axis. This height is 1 from the x-axis. This distance is going to be 4 minus 1, which means this height is 3 unit. In a right angle triangle, I have the perpendicular, I have the base. I need to find out the length of the hypotenuse. Which theorem do we use? We use Pythagoras theorem that says hypotenuse square is equals to base square plus perpendicular square. So hypotenuse is this. Let's say this is x. X square is equals to base square. Base is how long? 1. 1 square plus perpendicular is 3. So this is 3 square. X square is going to be 1 plus 9. X square is 10. In order to find out the value of x, I'll take the square root on both sides. X is going to be square root of 10, and 10 is not a perfect square, so I'll just leave it inside the square root. So this is how the distance between the 2 points can be calculated, in which both the components are changing. Let me give you one more task. I'm just picking up a random point here. This is x1, y1. Any point on any plane. There is no marking. This is just x1, y1. And then there is this one more point. Let's say this is x2, y2. I have picked up 2 points and I want you to find out the distance between these 2 points. So this is the distance that we are talking about. As I told you, you cannot find the distance between the 2 points in which both the components are changing. So what do you need to do? You draw a vertical line. You can continue drawing it. You draw a horizontal line so that you have a right triangle. As soon as you have the right triangle, you only need to find the base and the perpendicular. You will find the length of the hypotenuse by using the Pythagoras theorem. So, in this case, first of all, tell me the coordinates of this point. How far apart is this point? There is no scaling. These are the points for you. This point is at same distance as this, away from y. The distance away from y is shown by the x component. This point is x2 units away. So the x component of this point is going to be same as this, which is x2. And how high is this point? This point is at same height as this. And how high is this point? Height is shown by the y component of a point. So the height of this point is y1. Height of this point is y1. Distance along x-axis of this point is x2. Distance of this point along x-axis is x2. So what are going to be the coordinates of this point? x2, y1. As soon as you have the coordinates of this point, you have a pair of point which is horizontal, you have a pair of point which is vertical. How much is this distance? How do we find out the distance between two horizontal points? We only take the difference between x components. Y component are same. This is y1, this is also y1. This distance can be measured by finding out the difference between x components only, like I told you here. So this is x2, this is x1. x2 minus x1, the distance, the horizontal distance, and the vertical distance is measured by subtracting the component which is changing. And in vertical points, the only component which changes is the y component. x2, x2, they are same. This distance is going to be y2 minus y1. I have the base, I have the perpendicular, I have to find out the distance d between these 2 points. This is usually shown by modulus of d. So how much is that distance? I again use the Pythagoras theorem. hypotenuse square is equals to base square plus perpendicular square, and hypotenuse is modulus of d square is equals to, how much is the base? The base is x2 minus x1. So x2 minus x1 square plus, what is the perpendicular? Perpendicular is y2 minus y1 square. I have the value of modulus of d square. In order to find out the modulus of d only, I'll take square root on both sides, and this square root will cancel this. Modulus of d is equals to x2 minus x1 square plus y2 minus y1 square in the square root. So this is what the distance formula is. Distance formula is either mentioned like this, or the distance formula can also be measured in this way: a, b. A and B could be any 2 points between which we have to find out the distance, and the formula will then look like this. They both are appropriate, they both can be used. You can either mention the formula like this, or you can mention the formula like this. I hope this video will give you a much better understanding of how the formula is constructed, the distance formula. In the next video, we will be discussing few more examples of distance formula, and we will be discussing the application of distance formula, how many cases are there, and how we are going to use the distance formula. Thank you so much. That's it for the time being. Inshallah, in the next video, we will be discussing distance formula with few examples. Thank you so much.